The greenhouse effect. In this lesson, we'll explore the science and engineering practices of developing and using models, as well as the cross-cutting concepts of cause and effect, and stability and change. Warming Earth's atmosphere. Climate is affected by the conditions and components of the atmosphere. The Earth's atmosphere acts like the glass in a greenhouse. It is needed to keep the planet warm enough to sustain life. The sun releases radiation in the form of light waves. This radiation enters Earth's atmosphere and it warms the planet. The Earth also releases radiation in the form of heat. Specifically, we call this long-wave radiation. This radiation contributes to the warming of the planet. Some of the radiation from the sun is reflected by the Earth, and so it's released back to the atmosphere. So what is the greenhouse effect? The infrared radiation, or heat radiation, released by the Earth can pass through the atmosphere and into space. However, some of the radiation can be trapped in the atmosphere by gases. These gases are called greenhouse gases. The trapping of radiation by these gases warms the planet. This is called the greenhouse effect. Having some greenhouse gases is a good thing. If it wasn't for these gases, our planet would not maintain appropriate temperatures, and it would be too cold to live on. This animation will be used to illustrate the principles of the greenhouse effect. In stage 1, radiation from the sun in the form of light waves enters the atmosphere and warms the Earth. In stage 2, infrared radiation is produced by the Earth. We call this long-wave radiation. Some of this heat travels through the atmosphere and escapes off into space. In stage 3, greenhouse gases in the atmosphere absorb some of the heat. It is then reflected back to the Earth. This causes the temperature of the Earth to rise. In stage 4, increased levels of greenhouse gases in the atmosphere trap more of the emitted heat. This leads to a greater increase in the Earth's temperature. So what are the greenhouse gases? The Earth's atmosphere is made up of different gases. We're going to explore a number of those different types of gases. Infrared radiation produced by the Earth is absorbed by greenhouse gases. Carbon dioxide. It traps infrared radiation, and this warms the atmosphere. So carbon dioxide is a greenhouse gas. Methane. Methane also traps infrared radiation, and again, this warms the atmosphere. So this gas is a greenhouse gas. Nitrogen. Nitrogen makes up about 78% of our atmosphere. It does not trap infrared radiation, so this gas is not a greenhouse gas. Oxygen. Oxygen makes up about 21% of the atmosphere, but again, it does not trap infrared radiation, so it is not a greenhouse gas. Finally, water vapor. Water vapor does trap infrared radiation. This causes our atmosphere to warm, so water vapor is a greenhouse gas. So what is the order of events in the greenhouse effect? Stage 1, the Earth is warmed by light waves from the sun. Stage 2, the Earth produces infrared radiation. Stage 3, some infrared radiation escapes into outer space, and some is trapped by greenhouse gases. Stage 4, the Earth maintains a temperature suited to life. Stage 5, greenhouse gases in the atmosphere increase. And in Stage 6, more infrared radiation is trapped and the Earth's temperature increases. Increasing carbon dioxide. Many of our activities are increasing the amount of greenhouse gases released into the environment, or specifically found in the atmosphere. For example, carbon dioxide is a greenhouse gas released during the combustion of fossil fuels. The use of fossil fuels has increased since the Industrial Revolution. This coincides with an increase in atmospheric carbon dioxide levels. The Industrial Revolution took place between the 18th and 19th century. If we graphically represent temperatures during this same period of time through to today, we notice a gradual increase in worldwide temperature at the same time that we notice an increase in carbon dioxide levels in the atmosphere. Fossil fuels. Fossil fuels are carbon-based materials. They formed over millions of years from the remains of ancient plants and animals. Coal, petrol, and natural gas are all common types of fossil fuels that we use today. The use of fossil fuels is the major cause of increasing atmospheric carbon dioxide levels. Increasing human populations also increase the demand for these resources. As we have an increase in demand, there's going to be a greater amount of usage, and therefore a greater amount of carbon dioxide emitted into the atmosphere. Burning fossil fuels. Fossil fuels are burned to generate energy in a combustion reaction. A combustion reaction includes fossil fuels along with oxygen, and it produces carbon dioxide and water. This releases large amounts of carbon dioxide into the atmosphere each year. So how would limiting the use of fossil fuels affect our lifestyles? Fossil fuels are a major source of energy. Some uses of fossil fuels include transportation, so for example, cars and airplanes, generating electricity, like coal burning electrical plants, the making of plastics, the production of some medicines, and also the production of material like clothing. Deforestation and carbon dioxide. Deforestation is the removal of forests to make alternative use of the land. This is often to make way for human activities such as farming. Deforestation requires the combustion of fossil fuels for energy. This releases carbon dioxide into the atmosphere. The removal of trees and plants by deforestation reduces the amount of photosynthesis taking place. This causes an increase in carbon dioxide levels. Carbon dioxide is stored in trees and other plants. When we burn these trees or other plants, the carbon dioxide is released into the atmosphere. Increasing methane. Methane is an even stronger greenhouse gas than carbon dioxide. However, currently, the amount of methane in our atmosphere is pretty low. Methane is found in natural gas, a type of fossil fuel used for electricity, heating, and cooking. The increasing human population has caused an increase in methane. This is due to increased waste disposal. The decomposition of organic matter at landfills leads to the production of methane as bacteria outgas those things. Increased farming. Rice and cattle farming produce methane. While an increase in methane release has been observed, the release of methane from natural sources has remained relatively constant. This confirms that the methane released is from human activity. Methane is produced at landfills and also farms by anaerobic bacteria. The bacteria break down organic matter, such as cow manure and other wastes, and release methane.